Hey guys, this is Colin Warren from the WSU Aerospace Club, and in this video I'm going to be walking you all through a little tutorial I'm putting together for the intro rocket project for those who are interested in joining the WSU Aerospace Club, or at least helping build rockets and want to start getting rockets built. Through this project together, we're to give you a little overview, you can take a model I created in Solidworks, tweak some parameters, and then we use a program called OpenRocket where you can take the variables you tweak in SolidWorks, input those into OpenRocket, and then you can see what the predicted flight performance of your rocket is. And actually get pretty close. As we found out last year, we were using OpenRocket, and then we had a senior student using some more of his custom-made prediction software that took into account a lot more variables, and OpenRocket actually got within 100 feet. So it's a very powerful piece of software, so I figured it'd be good if we can help let you guys use SolidWorks, tweak some variables in that, and then even if you don't have any CAD experience, then go from that to OpenRocket, and allow you to start working with the rockets and give yourself a little intuition about that. So the first thing you're going to do, at least as this is more of a WSU Aerospace thing, if you're not already, make sure you're on our Slack. You can go down, create an account, put in your WSU email address, create an account. They'll send you an email to that. They'll send you a verification email. You'll hit accept. You put in your username, and then you're in. Once you're in, I'm going to quickly log into my account really quick. All right, once you're logged in, you're going to want to go to the Rocket Discussion tab, and then you're going to look for this little pinned message I have up above. It'll have all the resources for this tutorial. And in addition, as I'm posting this YouTube video, for you guys who aren't part of the WSU Aerospace Club, but want access to some of these links, I'll be posting these all in the comment, at least in the little description down below this video, so you guys can access at least most of them. Some of them are WSU explicitly. Now that you're part of the Slack, you joined, signed in, and you found the Rocket Discussion page, if you're not able to find it for a reason when you join it, you can go put in hashtag Rocket Discussion, and just hit enter. It'll say, do you want to join this channel? You can join the channel, and you can see this. Once you've done all that, let's go ahead and we'll jump into getting all the software set up so you guys can start using this tutorial and tweaking stuff. So the first thing we're going to do is we're going to download OpenRocket. We're going to openrocket.info. Just click download version 15.03. It'll start downloading. I'm going to cancel it. And then once you have it downloaded, drag it to whatever folder you want to launch it in. And make sure you know the file location of wherever you drag your OpenRocket file in, because this will become very important in a bit. Once you've done that, because it's a jar file, you actually have to have Java to run it. And if you're anything like me, even though you're pretty sure you had Java on your computer, it turns out you still have to go through some installation processes to get it all set up. So the next thing you're going to do is you're going to go to this Java download link. And again, it'll be posted on the Slack, or if you're watching on YouTube, click here. You want to download this free Java download, go through the process, install it. Then once you're done with that, I would say restart your computer just to make sure everything's installed correctly and everything like that. And then you have OpenRocket installed, and now you have Java installed. So now, how do you run OpenRocket? One would hope that you could just double click on it and it would work. And I'll go ahead and show you that I'm going to try it in mine. But yeah, sometimes you get this weird errors like cannot find file, stuff like that. So how exactly do you open OpenRocket? Because this is notoriously, I guess, clunky part of it. The way I have to end up opening OpenRocket is to use is it command prompt? Yes, there we go, the command prompt. If you're not familiar with command prompt or changing directories through, CD, dir, and everything like that, this is going to be a quick crash course in that. So I'll get into this part of it. So now that you have OpenRocket and Java installed, you're going to want to navigate to the folder that your OpenRocket project is in, but you're going to have to do that through this command prompt interface. So the command prompt interface, for those of you who aren't familiar with it, it's just like any other folder, kind of a hard drive interaction, interface where, okay, if you click on a folder, it opens it, you can hit back to navigate away from that given directory, etc. But instead of being able to click with a GUI, you actually have to type in stuff. So for instance, I'm in C /users /my folder. So if I want to go to the users folder, or if I want to navigate back to that, I have to use a command called cd ... And change directory, all that means, or CD stands for change directory, and the dot dot is the way the tell command prompt to go back one folder. So I hit enter, and now I'm in users. If I want to go and open a folder within users, obviously I can't see what folders are available to me right now. So how do I do that? I put in a command called dir, hit enter, and then this tells me, okay, date, everything like that. And on the right is the folder I want to open, or the available files that are open to me. So if I want to go back to my column war folder, I put in cd, I hit space, and then I start typing colon, but then I can hit tab, it'll auto-complete it, and if I hit enter, voila, I'm back in my folder again. So again, to review cd dot dot to move back, and then if you want to move forward into a given folder, hit dir to see what files are available to you, and then change directory, start typing your name, whatever thing it is, hit tab to autocomplete, boom. So now that you know that, I'm going to quickly navigate to where my OpenRocket is located, which is actually on another drive. So I'm going to have to change from my C drive to my D drive. So I'm putting D, colon, and then now I'm going to hit dir to see what folders are available to me. I know I'm keeping it in the Aerospace folder, so I can see Aerospace up here. I'm going to hit cd Aerospace and hit tab to autocomplete. dir to see what files are available to me, and there we are. We have OpenRocket. I can see it available in this folder. So now that once you've made sure you've had both of those, now we're going to use the command that will open OpenRocket. So we will type in java -jar, and then you'll put in the file name of your jar file that you want to open. In this case, it's OpenRocket. So I can start typing, but then again, I can use tab to autocomplete. So it recognizes, oh, okay, yeah, this is what you wanted to type. You hit enter, and there you go. You have successfully downloaded and opened OpenRocket in one of the most convoluted ways possible. And there we go. Now we have the interface for our program. So that's how you download, install, and open OpenRocket. The next thing we're going to do is we're going to install Solidworks as a WSU student. So if you're not a WSU student, you may want to skip over this part. So first off, the first thing you're going to go to is you're going to go to cougs.mme.wsu.edu. As I say in bold, make sure to download the correct version. One other thing, and I will show you in a sec actually by turning this off, because you may actually not see this bottom part. Disconnect. When you first click on the page, you'll see, oh, okay, free SolidWorks software, cool. But where all this text down below that told me how I can get it, where did that go? If the way that stuff down below that tells you how you can get the software pops up is you have to be on one of the school's servers, not servers, one of their Wi-Fi networks to be able to see it. If you're not on their Wi-Fi network, you have to use one of their VPNs to, I guess, fool their system into thinking your computer's there in using their system. And again, it's completely legal, as they have it on their website. So you want to click on the VPN link, and you'll want to go to the details for installing. And again, you'll want to follow the instructions. So SSL VPN client download. You want to download the SSL VPN client. So that will download. And then you just follow the installation process. And then you'll install the Cisco AnyConnect Secure Mobile Client installation. All right, so once you've done that, you'll want to navigate back. Again, very convoluted, I'm sorry. So yeah, you'll install that. Then you just follow these instructions. So you'll put in, when it first pops open, and actually I'll open it right now, there'll be a blank spot, so you'll put in this server name into it. You'll hit connect once you've done that. And then from there, it asks for username and password. Your username and your password are the same username and password you use to log into your My WSU account, Blackboard, what have you. So in my case, this is my Colin.Wharton account, so I'm going to log in to that using my password here. And then it's going to work its magic. And then I'm connected now to the WSU servers. So now, if I go back to the cougs.mme.wsu.edu, you're noticing, okay, I don't see it now, but if I refresh the page, boom, okay, now I have the steps for being able to access the WSU SolidWorks license. So from here, you'll want to go and follow this link first, go download the educational edition. You select the version. Make sure, because I made this mistake to begin with, make sure to select the correct version. As you see here, you will be able to download the 2017 to 2018 version. When I first installed it, I selected the 2018-2019 version. All this license stuff will not work for newer or older versions. You have to select the one that's on this page. So you go here, select 2017-2018 version. You put in your email address, you're a student, request download, and then you just follow the rest of these instructions to finish installing, get all that sorted out. And then once you've done all that, you worked your wonders, then you should have Solidworks on your computer that you can open anytime you're on the school network or anytime your VPN is on and running and it says you're connected to the school network. So now that my VPN's running, I can open Solidworks. It'll take a bit to load, but then I'll be able to successfully open it. So while I'm waiting for that to download, or wait for it to open, the next thing we're going to do is we're going to download the files for this project. So again, I've posted the link in the Rocket discussion subchannel on Slack. But for those of you who may not be part of Slack, again, I'll be posting this link down below the YouTube video. You can go and click the link and you'll get the Intro to Rocketry seminar files. Okay, got it. And then you'll just go here, download files. And yeah, from there, you'll be able to extract, unzip it, and then you can open all the files you'll need to use this project. So while we're doing that, also in the folder, there will be a file for OpenRocket that will come preset with the rocket that you're going to be able to tweak in SolidWorks. So open that, as I already have it opened on mine. I'm going to go to Open. I'm going to navigate to the folder. I have a file called nari.ork, which stands for OpenRocket. And I'm going to click that, and I'm going to hit Open. And this will be the OpenRocket file we will be using for this tutorial. So it has everything set up, nose cone, parachute, little shock cord, motor mount, everything like that. So now that you have everything set up, you have downloaded the Intro Rocketry seminar files, you have the SolidWorks file, you have OpenRocket, you're on Slack. Now, this is where the fun part begins about designing your rocket in OpenRocket, seeing how tweaking certain things will adjust the performance variables of your rocket. Then once you find variables that you like and that you want to actually make into an actual rocket, then we'll go into SolidWorks. We'll open the file I've made for this OpenRocket file, and you can actually tweak some of the variables, even if you don't have any CAD experience. So the first thing we're going to do, I'm just going to show you how to edit just basic parts. You have 3 tabs, flight simulations, motors configuration, rocket design. The first tab we'll look at is the rocket design, have a nose cone, and then the body tube with all the fins and everything like that. The parameters for this tutorial I've enabled you guys to tweak in SolidWorks is the body tube length. So you can go here, hit edit, and you can change the body tube length to 6 inches, 7 inches, and you can see it adjusted in real time. You hit close, and it will update in real time. So if you want to make, let's say we go to body tube, it's like, I want to see what happens if I make a body tube 7 inches. Then I'm looking at some variables over here. In this case, my calipers of stability, which tells me how stable the rocket is. And I'm noticing when I shorten my body tube length, oh look, my stability is going down. But if I up my body tube length, wow, it's going up. Okay, so maybe I want a longer rocket. One thing to note for this, as this will be eventually 3D printed, be aware of the max height of that your 3D printer can print. For the printers that are available for this tutorial, we'll be using Prusa MK 2.5s. I think that's what they are. And they have like a max height of 8 inches. So please do not make a body tube length higher than 8 inches or it will not print. And yeah, things will not go good. Also make sure your body tube length, just for stability purposes, and then there's some problems with the SolidWorks file where if you go below a certain inch, there's some things with the relations that goes down. You don't want to go below about 4 inches, 4.5. 5 inches, like you want at least 1.5 calipers of stability. So I would say don't go lower than 5 if you can. If you need to go lower, check in the SolidWorks to make sure the file won't break. Or if it does break, then if you have the expertise to tweak it, you can do that. But the long and the short of it, for you new people who don't have any SolidWorks experience and want to tweak things up, your range of numbers for this tutorial is you can go anywhere from 5 inches to 8 inches. That would be my suggested range for tweaking. And you can go anywhere in between. You can do type in 7.6. You can do that, what have you. Try not to mess with these other variables unless you know what you're doing, because then it won't completely match up the SolidWorks file. So in this case, I want to do a 7.5 inch rocket. So I do that, hit close, boom. So you can do that for the body tube. Nose cone, you can do that. I didn't really add. If you know how to work SolidWorks, you can feel free to tweak everything. So you can change the shape parameter. You definitely have to know what you're doing. There's nothing really easy in SolidWorks to allow you to do this. So I would say just leave the nose cone alone for now, unless you know what you're doing. So outside of the body tube, the other thing you can tweak is the fin set. So the things you can tweak here, you can tweak how many fins you want. You can go, I want 8 fins. Then you can look at your stability and see how that adjusts that. You can adjust fin rotation and fin cant. I didn't add variables in SolidWorks for the file. But the other things you can tweak is the root chord, tip chord, the height, and the sweep length. So you can tweak those things, play them with your heart's content, what have you. So actually, to give you more context, because you're like, okay, I guess it's seeming kind of convoluted about how do I know which variables I can tweak, which ones I can't. Let me go ahead and open the file, and then I'll show you really quickly and really easily, what values you can tweak. So when you open the file, the first thing you want to do is you're going to open an assembly. You can go in, go to your rocket, intro rocket, click on the double click on the rocket assembly, and it should open in SolidWorks. Once you do that, you'll right click on this body tube, and you'll go to open part in position. Sweet. So now once you've done that, you're going to want to you want to hover your mouse over the arrow up here because it hides some of the features. So you can expose those, and you want to go to tools, and you want to go to equations. Now this is where I've set up things where if you don't have a whole lot of SolidWorks experience, no worries, you can actually go in and tweak a bunch of variables on the fly. So if you take a look at the global variables over here, you're noticing a bunch of things you can tweak. So number of fins, root chord, tip chord, fin height. The nice thing is I've set up the tutorial such that if you tweak, I want to have 6 fins, number of fins, and I hit enter, it'll adjust on the fly. Now my rocket has 6 fins, cool. But now that I've done that, I can go into OpenRocket, I can go into my trapezoidal fin set, hit edit, and now I can actually tweak this on the fly and say, I can tweak it to 6 fins. What does that do? What does this change in SolidWorks do to my actual rocket? And I can do this with other variables. So if I see tip chord, I can go in here, tip chord 0.4. If I want to change that to 0.6 in, say, OpenRocket, I can do that. And I'll adjust that, and now I can go back to SolidWorks, hit that, hit enter, and it'll change it on the fly. One thing that may not be automatically checked when you open this that you'll want to check is the automatically rebuild function. Be sure to turn that on when you're making tweaks. That way, if you end up breaking something, so let's see if I can figure out a way to break this really quick. So I'm just going to mess around with things until I break it. So let's change, say, the root chord to 0.1. And you're going to get this warning, you're going to break something. So by doing that tweak, so you're going to hit stop and repair. And then what you want to do is go back to the original thing that you tweaked, change that you tweaked, and then adjust that to go back to the original file. You hit OK. And then you're noticing, it seems to have fixed it, but now there's only 1 fin. You'll want to look off to the left, and you'll actually see there's been some areas here that have been de-highlighted or look like they're inactive. The way to re-enable everything is to click this little blue bar here, drag it down, boom, everything's back to normal. So yeah, that's how you can go ahead. You can feel free to go in Tools, Equations, go into OpenRocket, say, I want to tweak the height. I want to tweak it to 4 inches. Okay, I'll tweak it to 4. I don't know. I like the look of this. So I'll go into fin height and I'll tweak it to 4 and see how that pops out. Looks like it's going to break something. So let's see, stop and repair. I will put it back to 1. And let's see what happens if we do 2. Will that break anything? Okay, that seems to be fine. Go to 3. Okay, it doesn't look like I can go up to 3. At least in regards to knowing what numbers break and which ones don't in SolidWorks, I wish I knew. I had a better answer. My best intuition is that I think SolidWorks has a different algorithm for how it calculates the different angles than OpenRocket does. Or maybe I think OpenRocket allows certain angles that are just, I guess, not physically possible when you actually put it on a model. So that's why it breaks in SolidWorks. So the best way, I guess, to figure out what numbers you want to do is, okay, make a model, tweak the numbers in OpenRocket. And you're like, oh, I kind of like this setup. Go in and see in OpenRocket if you can do that setup. And if you can't, go back, just keep tweaking numbers until things don't break. And then once everything's happy, drag it down. And everything should be nice and dandy. Some really weird looking rocket shapes. So that's how you tweak certain parameters in OpenRocket. Again, for this setup for Solidworks, I've allowed you to adjust the body tube and the fin, the number of fins. If you want to know which variables you can tweak, just find the corresponding variable in the Solidworks equations editor. One other thing that's not on OpenRocket that I did add is the angle of the lug. So if we go here, you'll notice if I put, like, let's say 8 fins, I adjust it, sometimes the launch lug will actually be in the way. Actually, let's go up to really extreme. I'll put up 12. I don't think OpenRocket allows you to do that. If you actually notice here, the launch lug is actually being blocked by the legs. Or by the fins, and the reason why you don't want this blocked is because there's actually going to be a rail this little guy slips onto. So you put your rocket, if you can see the camera, there'll be a rail that goes in here, and then when your rocket launches, this little guy here is going to be the thing that allows it to keep it stable for the first like 20 or 30 inches before it jumps off. So if you need to adjust the angle of that for any reason, you can go in here, let's say adjust to 80, and that will make sure if you do some really crazy wacky designs, you can slide it around a bit. So we'll adjust it to 75, and cool, it seems to fit in. So yeah, if you want a fucking 12-fin rocket, you can do that. You're just kind of insane, to be honest. So yeah, feel free, jump between SolidWorks' equation editor and OpenRocket, tweak to your heart's content. In terms of how to know whether your rocket's going to do well or not, or what tweaks you should make, there's a few variables you should look at. One is your calipers of stability over here. Caliper is based on like the diameter of your rocket. So if you have 1 caliper of stability, actually taking it back, the caliper of stability is based on your center of gravity versus your center of pressure. So for rockets, you want the center of gravity to be further ahead of the center of pressure, and you want at least 1 caliper of stability minimum for it to be like somewhat semi-stable at all. Most people suggest at least 1.5 to 2 calipers of stability. So you'll want to tweak numbers until you get at least 1.5. In this case, I have 2, so I should be fine. But let's say go in here and edit. Knock it down to like 5. Okay, so 1.17, that will work, but there's not enough margin of safety, so I might bump it up to 6. Okay, 6 inches seems to be good. So that's one variable I want to keep track of. Another variable you'll be keeping track of is apogee. Is how high your rocket goes. To do that, you're not going to see one right away because we don't have a motor configuration. So to set up a motor configuration, we're going to go in here to the new tab. We're going to create a new configuration, and we are going to select a motor. So in here, there's a big database of a bunch of different rocket motors that are available to you from different manufacturers. We're going to be using mostly Estes motors from A to C. So we can clear all. We'll go to Estes. Let's select on Estes. A to C is about the rocket range that fits in here. And now you have all these different rocket motors that can work for you. The way these are classified is A is the lowest impulse motor or the least powerful, and it goes all the way to O, which is like the most powerful motor. Like Space Shuttle uses like I don't remember which one, but I think they use like double O motors or something crazy like that. But yeah, basically if you have A, that's the lowest power, lowest impulse, and if the higher up you go, the higher up the alphabet you go, the stronger the motor gets, and it's like a doubling of impulse for each one. For those of you who are a little bit more tech savvy. So for this one, we're just going to do a classic B4 because I think that's what the WSU Aerospace Club has a lot of. So we'll hit OK. We selected it. And now you notice, okay, if I click here, I have my B42 motor configuration. And now on the bottom left, I have numbers. And it'll tell me, okay, using a B42 motor, this thing will go up to 108 feet. It's going to have a max velocity to that, max acceleration to that. So if you want to go as high as possible, that's what you're going to go and tweak in your design. So usually making your rocket lighter is usually better for a given motor. You can look into things like rocket equation and stuff like that to figure out how to optimize apogee. In addition to just tweaking around, if you actually want to be a little bit more methodical, I've also attached a great NASA beginner's guide website that you can click through here, where they've compiled a bunch of things in regards to rockets that you look for. So you can look at forces on a rocket, weight, thrust to weight ratios, stuff like that. Everything you need for like a quick crash course here is available through this site. So I would suggest, I mean, obviously you can tweak things and you'll still start to see, oh, if I have my fins configured a certain way, rockets will go higher versus lower. But if you want to do a less trial and error method, going to this website, clicking through, and just reading through and understanding a lot of these concepts, it makes it a lot more methodical in how you do it. I would focus on the rocket fundamentals first, and then you can go on to model rockets would be the next one. It would be the next section I look at. And then, you can feel free to jump between all the other ones, because this is pretty much every topic, at least from a beginner's level, that you would look at if you're considering forces on a rocket, how to best optimize that. That's highly suggested. So once you've kind of jumped between the rocket index, you've messed around with some things, you went in here, let's say, I want to have a root chord of that, and root chord of that, like 0.9 inches, and I know it's actually go higher. Oh, cool. And then I want to have more apogee for my given rocket, so I would keep that configuration. Once I have all those set up, I can run a flight simulation. So I can go in, click New Simulation, and you can input all the parameters from like wind speed for the day, what the turbulence is, wind direction, stuff like that, where you're located in the world, and if you want to get to that level of granularity, what the length of your launch rod is. Feel free to ask, as we're in the club, you can ask your various rocket lead mentors where to get these numbers, or even then, just a quick Google search for your latitude and longitude. You can see, okay, like if I went and let's say I'm in Pullman, Washington right now. So let's say I type in Pullman, Washington, longitude, latitude. So I can put in these numbers here. So I put in 46 and 117, what altitude I'm at. So I can look that up and I can see, okay, wind speed for Pullman, Washington. If I were to launch right now, it's 11 miles an hour, so I can tweak that. It'll tell me the direction. It looks like it's a northeast, like about northeasterly wind. So wind direction will be based off of, I think clockwise is how it goes. So 90 degrees is due east. So I would adjust for this wind, I would say like 80 degrees. And that would take into account that. So you can just go in, look up all these variables, ask around to see if there's certain variables. And then once you have your setup, you're sure it's pretty accurate to what your conditions are. You can hit simulate and plot. And you'll see, okay, for your x-axis, for you guys who like your 2D Cartesian coordinate systems, your x-axis, okay, over time, what variables do you want to keep track of? For this one, I'm just concerned about altitude. So I'm just going to plot altitude as a y versus time as an x. So I'm going to hit plot. You can have different time events where you can mark off. And then it'll show over time for as many seconds, okay, how quickly, at 3 seconds, it looks like I'm going to hit apogee. At 19 seconds, I should expect my rocket to come down, stuff like that with the given setup. This is your prediction for your given rocket setup when you print it off the 3D printer of what it's going to be. That's pretty cool. And you can actually launch a rocket, and you'll actually see how closely it correlates to the simulation. If it didn't, like what variables did you forget to take into account, what have you, were there things you could have improved on, stuff like that. I think that's pretty cool, and it's actually pretty accurate too, so that's even better. So we'll close this. And if you want to go back to the simulation at any time, you can click Run Simulation. All right, just double click it, edit, and you just hit Simulate and Plot again. Plot, and boom, you get that simulation again. So you can feel free, go in to do, you can select new configurations, do different motors, different designs, remove motors, what have you. Just generally tweak things around and see if you can get something that you like. In addition, if you want cool 3D view, if you click the unfinished view, you can see your rocket there. Go back to the side view. So that's a lot of like, in terms of setting up your rocket, tweaking it. Those are the main things you look at. Tweak it in OpenRocket so you get a design you like, using the variables that are available to you in the equation editor, or if you're more Solidworks savvy, you can actually manually go in and create the file itself. And then once you've done that, you can go in, create motor configurations, flight simulations, and then you can tweak your model as you like it. Then once you have a tweaked model that you like, you'll hit OK. You'll save your model, in this case, this wacky thing. You're going to close out of this one, and then you're going to want to make sure you can open this rocket assembly thing again. It may ask if you want to rebuild. In this case, if it's not rebuilt, you'll hit this rebuild button up here. You hit save. And then, because you'll want to have this printed, in order to have your rocket design printed, you'll go up to your file. You'll go to save as, and then you'll go to your folder. You'll go to STL, and then you'll hit save. In this case, I already have STL saved from a previous rocket I designed. And then you'll take those files, you put it on a flash drive, you'll give it to your rocket lead or whoever's doing the printing. They'll put it into whatever program that formats your STL to G-code. In my case, I use Slicer, Slicer PE for the Prusa edition. And then from there, you print it on your bed. You just assemble it all together. And then you have a fully functioning rocket that you can go and test and launch, and then you can see how high it goes and whether it matched your predictions. So yeah, that's pretty much the whole overview of what you can do with this Intro to Rocketry course. Again, make sure you have the files installed, OpenRocket. If you, for whatever reason, you want to get a nice tutorial about how to use OpenRocket more in depth, if you go to the help, it has a really nice guided tours. I would highly suggest going through both of those. There's some really cool other rocket optimization tools you can use for if you want to optimize for height, what you want to, at least what parameters you want to input and stuff. So there's much more intermediate and advanced options for you. So yeah, feel free to mess around, tweak it to your heart's content. And once you're done with that, export as an STL. And then you'll have a rocket you can launch. A couple notes for at least the WSU Aerospace Club, actually, and for some other clubs in general, I'm sure it would be helpful. Again, for your body tube length, make sure it's no longer than 8 inches to get it printed for free. Again, this may change. This video may be dated because maybe we get bigger printers. But be sure to ask your rocket lead or whoever's teaching this course or whoever you're printing from. Figure out what the max height is and don't print higher than that. And I say for this rocket, don't go lower than 5 inches because in the Solidworks model, again, if we go to the tools and equations, we have to go open the part file. And now if we go to equations, if your body tube length goes below a certain length, let's say 3, certain parts just don't start to work. Like for instance, the launch lug is a little bit off, like 3 inches, things just start to break. So if you can keep it at 5, that's about nice. Maybe you can go down to 4. Yeah, 4 if you really want to, but I would suggest no lower than 4 at most. So yeah, that's the only other note for at least for things to not do when you break it, to break the SolidWorks model. If you do, hit up somebody in the Aerospace Club that can help you sort it out, or someone with SolidWorks experience. So yeah, without further ado, thanks again for watching. Hopefully this has been helpful. You now have all the resources to build and launch your own first 3D printed rocket. So from here, once you get good at this, making models, you can actually go ahead and let's learn SolidWorks to see how I can make this model from scratch without using the equation editor from this pre-made file. Or how can I, maybe use a little bit more, maybe make my own more advanced OpenRocket simulation, stuff like that. And yeah, that will just allow you to really explore the rocketry topic and just really take off. But hopefully this first project will give you a good first start. So without further ado, happy rocket building. Hopefully this has been helpful. And yeah, I'll hopefully catch some of you guys in person, or for the rest of you who are just watching this through the internet, thanks again for watching my virtual self talk about rockets and intro projects and all that.